So to do now, current exert force on dash. Alright, take a few seconds and try to. Today our topic is force on current in magnetic field. You okay? The other student is okay? Alright. So current exert force on. Yeah.
Oh, I have a.
You have something?
It should be electron, right?
Yes, self. Okay.
It could be an electron because electrons make current,
Let
right?
me see. Electron.
Electrons make
No. So the current exert force on magnet.
Oh!
Electron is the one that.
I know!
Electron is the
It
one that.
makes sense.
Electron is the one that carries the charge, and when electron carries the charge, it creates current. So a magnet.
I get it! I get it!
Alright.
Can I make an inference?
Hold on. Who discovered that?
And
And or-
something?
Han Orsted, remember from the last lesson?
Oh,
Hans Ørsted from Denmark. Okay?
okay.
Now, what I want you to use Newton's third law. What are you going to be using?
Newton's third law.
Newton.
Yeah, that's the inference I was going to make. Because
Hold on.
we
Yeah, sure. Sure, tell me. Yeah.
Because we knew something from the last lesson that magnets affect current. Because we saw the magnet is a compass in the current. So then with Newton's third law, the current should exert a force back on the magnet. That's my inference. I should have thought of that before.
So, what is your inference? Magnet?
Magnets exert forces on currents to make them a little different. So currents must exert forces back. I should have made that inference in the beginning.
So, magnet. Exert force. Force what?
On
On
the
current.
current.
On current.
And according to Newton's third law,
So-
AB equal to F negative BA.
So the way the French Charles Coulomb used Newton universal law of gravity to write the statoelectric force equation, the same way Hans Ørsted, Hans Ørsted used Newton's third law to make the inference that the current exert force on
magnet.
magnet and magnet exert force on current. Both of them done by who? Hans Ørsted. Now I'm gonna show you a little demo, and then after that little demo, we're gonna go to the
demonstration?
demonstration. Okay. I invite my class who wanna come to do the demo.
Can I come?
Okay, come. So you're gonna hold this one. All right, hold this one in front of me. And I have two magnet. I have two bar magnet. One has south and north, the poles, and one doesn't have poles. Okay.
So what
So-
are we gonna guess?
You're gonna have to guess. Okay, that's part of the do now. Okay.
Based on what? Are we just blindly guessing?
Now, based on what you see, based on observation
Oh.
and your prior
So
experience.
this is
So-
what
This is, you see what? This is south.
Okay.
This is south, right? And I'm gonna bring it very close. Very close. As I bring it close, the other one what? Oh,
Whoa, it's
okay.
trash.
Attracts. So now then
Oh
then you
my.
tell me then what is this one?
Has to be north.
Has to be?
Yes, it's north
North.
because south attracts more north because opposites attract.
Okay, now let's see the other side. Okay? Hold on. Don't lean too much. Okay? So let's see what happened.
It's repelling. It's repelling.
Let's
I
see.
knew it. It must be the south pole. because-
Wow.
So it
It must be
repelling.
the south
So
pole.
much that
That
it
means that means what side is it?
south.
This is south pole and this is south pole, south pole, like pole
Repel.
repels. Okay, let's go back.
Alright, that was fun.
Okay, I'm glad that was fun. Now we're gonna go back to the lesson. Okay? Is that okay?
Yeah.
All right. remember one thing, that the current can exert force on magnet, and magnet can exert force on
Current.
We learned that in the do not.
yes. Thanks to Newton and thanks to
Hands or step.
Hans Ørsted.
Thank you, Orsted.
Or step.
You should also say thank you, Ørsted.
Thank you or step.
Okay.
Yeah, you should be grateful to him.
Yeah, we should be grateful to them. Alright, lesson. Okay, so now I'm gonna give you a magnet.
A magnet? Is that like one of the horseshoe magnets that
Yeah.
I don't really see?
That's right. So I'm gonna give you a north and south pole, and what I want you to do, I want you to draw the magnetic field lines. Go ahead, draw it, and I'll show it to the people. Quickly draw it. Okay, now I see one student did draw it. One student draw, he got confused. The magnetic field only one direction, not both direction, okay?
Okay.
So, alright, so let me see the other student.
That's right.
Other student, yeah, that's correct. The magnetic field lines start at north, goes to the
No.
south.
Because, I know.
So-
I did this because of my information prior from the bar magnet.
Okay,
Because the north
Okay.
goes to the south in a sort of curvy
That's
pattern,
right.
and I know that prior.
okay,
So I do this.
okay, very good.
That's what I did.
So this is what? What do you call it? A magnetic?
Field.
This is magnetic field, right?
Yeah.
Now we're gonna draw a battery. Why we're gonna draw a battery? We're gonna create electric circuit.
Oh.
The battery is a source of voltage.
Huh.
Now-
So are both of them on one side? Why? I
Okay.
guess we don't.
Alright, so this is the battery, right?
Mm-hmm.
So battery, do you need
I
wire?
guess it's a sideways battery.
You do. Because
Okay.
you will make a circuit.
I guess it's a sideways battery.
Alright, so here is the battery. Does that make sense?
Yeah.
This is the battery
Yeah.
and this is the wire. That means this is the circuit. So which one is the circuit? The orange one is the electric.
Circuit.
The orange one is the electric circuit. Now, what I want you to draw, I want you to draw the direction of the current. Go ahead, take a few seconds and draw the direction of the current. And let me know when you're done. Okay, so I see Albert is done. He draw the direction of the current, and that is wrong.
Let me.
The current goes from positive terminal to negative
What is
terminal.
wrong with
So that is
diagram? Give me some more time and I will finish.
no, just one is fine.
Give me.
Okay, this is correct. So the current starts from
Because
positive terminal
the
and
current
goes to
the same way as the electric circuit. The electrons flow the same way as the electric circuit, right?
yeah. When we're gonna talk only one person at a time, okay?
Okay.
All right. So I see you. You did the right thing. The current starts from positive terminal and goes to the.
Negative.
Good job. Keep up your hard work. Okay. So this is what Isaac draw. He draw that the current, the direction of the current is what?
Yeah, with the circuit.
Positive to negative.
From positive to
Terminal to negative.
the
Yeah.
negative terminal.
It goes with the circuit.
Yeah. So it starts positive terminal and goes to the
Negative.
negative terminal. This is the direction of the current. Now, today I'm going to teach you another rule that's called right hand rule. What is that?
Right.
Right.
Right hand
Didn't
rule.
we talk about this?
Yesterday we talked about the right hand rule for what? To find what? The
Magnetic
direction of
field.
magnetic field.
Field.
Today we're going to do the right hand rule to find the direction of the
Magnetic force.
magnetic force. Right hand rule. Alright, right hand rule. Okay. Now what are you going to do? Do we have a hand?
Yes.
Alright, everyone have a hand.
We know about this, so
Okay.
I think I don't know. I don't really know.
Okay. So what are you going to do? Please focus first before you jump
It
in.
has something to do with the right hand, right?
Yes. So first you observe, and then I'm gonna ask you to come to the board and show the demo. Okay?
Okay.
So please focus. All right. Now, what are you gonna do? You're gonna put your fingers at the direction of the
Magnetic field.
current. At the direction of the what?
Current.
Current. put your four fingers at the direction of the
Correct.
current. Okay. Your thumb is inside your
Hand.
hand, inside the palm. Okay. Now you're gonna curl your fingers at the direction of the
Magnetic field.
magnetic field.
Which is always perpendicular, so it just like curls
It's not
like
perpendicular. The direction of the magnetic, the direction is to the east. The direction of this black line to the east. Curl your finger to the
East.
east, and then take up the thumb.
Thumb.
So what is the direction of the magnetic force?
North.
To the north. So we're gonna draw the direction of the magnetic force. Now who wanna come to show that first?
Oh,
Can I count?
Okay, first Isaac come, and then Albert come. Okay.
So,
Hold on. Make sure you don't block. Okay.
So this is my right hand. I'm going to.
Your thumb finger is inside.
Oh yeah.
Okay.
My thumb finger is inside.
So direction of the current,
Yeah, this is the.
diagonal direction of the current.
Yeah, this
Alright.
is the direction of the current. Let's curl
Curl this way. Curl at the direction of the what?
over
Direction of the magnetic field.
And then the thumb points out on top.
On what? So at the direct.
Around north.
North.
here.
So this is magnetic field, magnetic force. Okay, now
Oh, Bert, I think we can.
Let's try.
go left, slide,
Okay.
go to
Point-
the other side. Go to the other side.
Point to current.
Current.
Count to
Curl to the direction of the
magnetic,
magnetic field, which is the east. So make sure east. Those fingers are to the east.
Okay.
Here is to the
Yes.
east.
Yes.
So this is east. If you guys don't know, this is east.
Oh yeah,
And
you
this
should
is-
know your
West.
Well,
So the fingers, the nails are to the east, right?
yeah.
And then take out your thumb. Now which is at the direction of the
Magnetic force.
magnetic force. Now, very good.
Wow.
Now I want you to use this understanding to find the relationship between these two.
Wait.
The relationship between current and magnetic force. The relationship between magnetic field and magnetic
I
force.
think I can do this. Just let me analyze my thumb up for a bit.
Yeah, just write it down. Just
Let me
write it down.
analyze this. There's a particular way it's just.
I'm gonna rotate around in case you need help, okay?
No.
I'm gonna rotate. I'm gonna rotate around. Make sure you need any help.
Like, it's a right angle. That's
Okay.
a particular-
I'm gonna give you some hint, okay?
Oh,
Does it have something to do with the right
I'm gonna
angle?
give you some
hint.
hint. So this is the current, right?
Yeah.
The green is current, and the black is
Magnetic force.
black is
Magnetic force.
magnetic force, and
Whoa.
this one could be
Magnetic field.
magnetic field.
Wait, this looks
Wow.
like the XYZ plate.
Uh-huh.
I know my XYZ
Very
plate.
good. So
They're
this is
all perpendicular.
very good. Very good. This guy is good. Very good. So what is the relationship between these two?
Perpendicular.
Perpendicular. What is the
Those
relationship?
are perpendicular too.
Very good. Awesome.
That's definitely not how you write an ampersand at the
Okay, so this is how I write perpendicular. Is that okay with you guys?
Yeah,
Yes.
Okay.
that's the symbol.
All right. So move on. Let's move in on. So I'm gonna give you a problem, and you're gonna.
Can you pass the ratio?
All right. You're gonna solve the problem. So what I'm gonna have a magnetic field. I'm gonna have what? A magnetic field. What I have? A magnetic field. Let's say this is the magnitude is 0.9
Tesla.
Tesla. I have a current.
I need to
can
clear
the-
my board.
Can the current be
Can
30
you
amps?
pass the razor to me, please?
Yeah. Current is how much you want?
30 amps.
So the current is 30 amps, and what is the length you want?
Maybe 12 centimeters.
Length is 12 centimeter. And the degree, what degree you want?
Maybe 60.
I guess.
60 degree. Alright,
Why we guess the same thing?
what I want you to find, I want you to find the magnitude of what?
Magnetic force.
Magnetic force. Go ahead, good luck. If you don't know the equation, you should be able to kind of conceptualize the equation from the
Over
information.
2 pi r?
No,
Because we-
that's magnetic field.
Oh.
Common misconception. So the magnetic field is, do we have I?
Yes.
I. Do we have L?
Yes.
Do we have B?
B.
Yes.
So ILB.
Do we have 60?
Yes.
So then there has to be some type of
Like,
trigonometry. Okay, now go ahead find it. Go ahead find it.
that looks a lot like a symbol. So let me write down my information. So 60 degrees, its length is 12 centimeters, and I equals 30 amps.
Okay.
Wait, oh, it's around 2.8, I think.
Is it 2.8?
I think that's what it is.
Let's see. FB is equal to I is how much? 30. And L is how much?
0.12.
0.12. Because you have to divide by 100.
Yeah.
B is
B is 0.9.
0.9 Tesla. And sine
60.
60. Sine 60 is 0.87, right?
Yeah.
So what do you get?
2.8 newtons.
2.8 Newton. Alright, very good. Now exit slip. Now, what are we going to do now?
Exit slip?
Exit slip. Are you having fun?
Yes.
Yeah. I mean, it's clear that this guy over here is being sarcastic.
I'm not. I
Exit slip.
learned a lot today.
Let's see. Alright, now I'm going to give you a field and
Fuel with 12 X's, now that's gonna be a hassle to draw.
this is field representing by two-dimensional geometry. So this is the field. Now you tell me what is the direction of this field by looking at this cross.
Do the right hand rule?
No. Don't do it. This is by convention. What is
Down.
it? What is this field? This is north. That's common misconception. This is not north.
You said down, that's south. You gotta do your compasses right.
So what is this? This is
Um,
inside the board.
inside the
Entering the into the board. Does that make sense?
Yes.
Into the page or outside the out from the page?
Into.
Into the page.
out
In,
from the page is on the opposite side.
into the board.
Out of the board is on the opposite side, right?
Okay, yeah, that's true. Now what do you want me to do now? Do you? Oh, okay, I can give you the magnitude of this electric field. So let's say,
Maybe
what
you
is it?
can say 20 amps.
Not 20 amps. That
Oh,
doesn't
4
even make
Teslas.
sense. Tesla.
4 Teslas.
So Tesla. Amps is the current.
That
This
is
is
one ungodly magnetic field.
okay. This is 4 Tesla, right?
Mm-hmm.
Yeah, 4 Tesla is like MRI is 1 Tesla. The Earth magnetic field is
80,000 times less than this.
oh 80,000 times. Yeah, maybe. Is it 5 times 10 raised to negative 5?
For my calculations before, it was 20,000 times weaker than the MRI.
So
So
that
the
means it's 80,000 times
Yeah.
weaker.
All right. Okay. Now what can we have? We can have a wire.
Wire, maybe 50 centimeters long.
Wire. What direction you want?
That is one
To
long
the
wire.
right.
To the right.
Yeah.
So wire is to the right. Let's put it to the right.
Maybe east.
East. Okay. And current is how much you want?
20 amps maybe.
20 amps to the east, as you said. All right. Now I wanna. You wanna give me the length of the wire?
50 centimeters.
Yeah.
50 centimeter.
That's
All right. What do you want? What I want you to find? I want you to find electric. No, a magnetic force. All right. Go ahead. Find the magnetic force. As you know that magnetic force is what?
LBI sine theta.
Okay. Go. Good luck.
LBI.
I'm gonna give you a few seconds to do that.
Hmm.
First, you have to find the direction. Make sure you understand that because I did not give you the angle. So you have to use your right hand.
154.
Let me know once you have the answer. Waiting.
This would be perpendicular to that. So
Huh?
no,
Yes.
no.
Yes.
Give me some
Yes.
more time. Times 20 times 4. So, 0.5 times 80 is 40.
Okay.
So
So,
that's
all right. So Albert got 40. That means you have paying attention today. You pay attention to do now and lesson. That's why you got it right in the existed. That's what it should be.
Here's mine.
And the other student, he also got 40, and that's very good. That's very good. Now let's explain.
Right-hand rule.
Let's explain how the right hand rule works. You tell me what to do with my hand since I have one.
point
Okay.
to the direction of the magnetic
No, point to the direction of the current. Call at the direction of the.
magnetic field
So it's going inside the
board
board, right?
Yeah.
And then
Into the
and then it's sticking out.
down to the north.
So it's to the north.
Perfect. And we saw the peculiar that we saw that it was peculiarly perpendicular. So we know that if that's there, then it must be a 90-degree angle.
All right, so that's correct. So then it must be 90 degree, right? So current is how much?
I'm
90
20?
degrees.
Oh, I'm sorry. 20.
50
Pay attention.
centimeters is
0.50.
0.5.
B is
You don't have to put 0.50.
4 and sine 90, right?
Yes.
So and that gives you 40 what?
Newtons.
Newtons.
Because 20 times 0.5 is 10 times
40
4.
Newton to what? J. Right? I, J, K.
Yeah.
Can you put that?
Because J
Yeah.
is the Y, right?
J is the Y. Yeah.
40 newtons in the J
See,
direction.
I know my vectors.
You know your vectors. Okay. All right, I'll see you tomorrow, guys.
Bye.
Bye.